Lesson 7-4, Special Right Triangles. By the end of today's lesson, we will be able to successfully use the relationships among the sides in special right triangles. For the 45-45-90 degree triangle theorem, it states that the hypotenuse is square root of 2 times as long as each leg. So to calculate the length of the hypotenuse, we take the leg x and we just multiply it by square root of 2. And the extended ratio for the side lengths of a 45-45-90 degree triangle is 1:1 to square root of 2. It could become useful later. And to prove this theorem, we can go ahead and just use the Pythagorean theorem, x squared plus x squared, and I'm just going to let the hypotenuse be c squared, and this is 2x squared. So take the square root. Hypotenuse c will just be x square root of 2. Example 1. Find the length of the hypotenuse. So we simply take 6 and we multiply by square root of 2. And for this, part B, example, we're given the length of the legs. So we can simply just take the length of one leg, 4 square root of 2, and multiply by another square root of 2. So this would be 4 times 2, which equals to 8. Example 2. Find the lengths of the variable in each triangle. Now, here they give you the length of the hypotenuse, and they want you to find the length of each leg. So we'll have to do the inverse. 9 square root of 2 divided by square root of 2, which is just 9. And for part B, again, they gave you the length of each leg. So I'm just going to take one of them, 2 square root of 2, and multiply by another square root of 2. So this would be 4. And part C, again, gave you the hypotenuse, the length of the hypotenuse. So I just have to do the inverse by dividing by square root of 2, which is 12. And now we have the 30-60-90 degree triangle theorem. In this theorem, it states that the hypotenuse is 2 times as long as the shorter leg, x. So we will always refer to the shorter leg as our reference point. And the theorem also states that the longer leg is square root of 3 times as long as the shorter leg. So again, here from x to the hypotenuse, we multiply by 2. X to the longer leg, we multiply by square root of 3. So again, hypotenuse equals 2 times shorter leg, and the longer leg equals the shorter leg times the square root of 3. To prove this theorem, we can take this triangle here and draw the other half of it and form an equilateral triangle. So this would be x. So this obviously has to be 2x. And if we use the Pythagorean theorem to check if the altitude is x square root of 3, we could square this, which is 4x squared, and then subtract x squared to get 3x squared. And then we could take the square root of this, and this would be x square root of 3, which equals your altitude. Example 3. You make a guitar pick that resembles an equilateral triangle. So I'm going to draw an equilateral triangle with side lengths 32 millimeters. What is the approximate height of the pick? So I'm going to draw an altitude to the opposite side of one of its sides, and it's going to bisect this one side here, and then I know this is 60 degrees, and this is 90 degrees, and this will be 30 degrees, and half of 32 is 16. So going to use a theorem here. I'm going to take 16. I'm going to multiply by the square root of 3. And this will be your height. Example 4. Find the value of the variables. Write your answer in simplest radical form. Okay, so this is a 30, 60, 90 triangle. And since I have the length of the longer leg, and then I want to calculate for x, then I have to take 8 and divide by square root of 3. So x would be equal to 8 square root of 3 over 3. And to calculate y, I'm going to have to take x and multiply by 2. And that would be 16 square root of 3 over 3. And for part B, to calculate x, I need to take 2 square root of 3 and multiply by square root of 3. So this makes 6. And for part C, and I noticed that this is an equilateral triangle, so I can make the conclusion that this angle here is 60 degrees, this angle here is 30 degrees. So the height here, I can just take 6 and multiply by square root of 3. Example 5. A car is turned off while the windshield wipers are moving. The 24-inch wipers stop, making a 60-degree angle at the bottom of the windshield. How far from the bottom of the windshield are the ends of the wipers? So basically we're calculating for this length here. So since this is a 30, 60 degree 90 triangle, x can be calculated by taking the length of the windshield and dividing that by 2. So that would be 12 inches.